Hello, my name is Vincent Van Buren, and this video is about scales of measurement. As a primer to discussing concepts in biostatistics, we first need to describe the different scales of measurement. The importance of this discussion is that different scales of measurement require different considerations for experimental design and analysis. The first scale of measurement listed here is nominal, where the data are unordered categories. The dichotomous example given is lung cancer or no lung cancer, where the data are counts for each category. There can be more than two nominal categories. The second scale listed is ordinal, where the data are counts from ordered categories. Survey responses such as agree, strongly agree, disagree, or strongly disagree are examples of ordered categories. Interval scales are used for numerical values where an interval difference would be interpreted the same way throughout the scale. For example, a 2-degree difference in temperature means the same thing in the interval 0 degrees to 2 degrees as the interval 100 degrees to 102 degrees. Finally, the ratio scale of measurement is just a special type of interval scale that has a true zero. Analysis of data measured on a ratio scale can lead to meaningful assertions of fold differences, or ratios, between two values. Ratio scales are common in medicine. For example, age, weight, heart rate, metabolic concentrations, etc. are all different types of ratio scale measurements. Because the ratio scale is a type of interval scale, any statistical approaches appropriate for the interval data can be used for ratio data. Different scales of measurement require different approaches to how samples are compared. Nominal data are collected as counts of observations belonging to different categories, and samples are compared as proportions of observations belonging to a category of interest. Chi-square analysis is often used for making such comparisons. To compare samples measured on an ordinal scale, we use rank-based tests such as the Mann-Whitney rank sum test. To compare samples collected on an interval or ratio scale, means are typically compared using ANOVA for 3 or more groups, followed by t-tests for pairwise comparisons. The measurement scale and characteristics of the data's distribution contribute to our selection of an appropriate statistical test. Here we'll discuss parametric versus non-parametric tests. Interval and ratio data typically follow a normal distribution. Normal distributions are well defined by the parameters mean and standard deviation. We use samples of a population to estimate the mean and standard deviation to examine possible differences between two or more groups. A central question asked by a statistical test is the observed difference in means, for example, a likely true difference of the groups, or just a result of random variance in the samples? Test statistics are metrics for examining the differences between groups. For interval and ratio data, comparing these test statistics assumes that the underlying data follow a normal distribution and are called parametric tests because they rely on the mean and standard deviation of the observed data. Non-parametric tests, on the other hand, are procedures that are used for nominal and ordinal data, or when interval data or ordinal data are clearly not normally distributed. So we only use these non-parametric tests for those situations where the data are clearly not normally distributed. And we'll talk about that again in another video on normal distributions. Thank you for your attention.